Hello, you rates. Thank you to whoever's asking about donations. This is the first time I've tried to go live or live video because I know there's a bit of a catch with Zoom. But I'm just gonna wait a few minutes because I would really like the whole class in because electricity is really not the easiest thing, and I know there's lots of questions. And I'm hoping people can sign in and then ask me questions so that I can try and break down what we've done so far for you. So I'm just gonna hang around for like a minute and hopefully more people will join. If there's any other year eights struggling, then you can send them the link. That's absolutely fine. So thank you, Ben, for doing that. But yeah, anyone else struggling, you can send them the link. I'm going to try and summarize series, parallel, what an ammeter does, what the voltmeter does, and then give you the answers to the worksheet from last lesson to show you why it looked more confusing than it needed to be. So yeah, I'll just hold on for a second. Can you give me a thumbs up as well if you can hear me okay, etc., just so I know if I need to do any technical glitches? Thank you. It's just much easier. Fabulous. You have been heard. Brilliant, Oscar. Like to know you still got your humour. Thank you so. Yeah, thumbs up will be brilliant. The emoji, awesome. So all your keep your chat like questions and interactive. So anything that I say that you're not sure about, pause me and I will try and explain it in a different way. That's the whole idea, is it's a bit more interactive, because otherwise I get emails about questions, and if I'm dealing with another student, it's really hard for me to get to you and try and explain it in a clearer way by email. It's just a little bit tricky. Okay, so how we do it? Right, hopefully most people are in. I've got about 16 at the moment, so that's nearly all our class. I think there's a few that might be missing, but we'll get there. Okay, and also just so that you're aware, because I've done YouTube videos and things before, I'm more than happy if I'm going through any information, if you do want to screenshot it to come back to it or write notes up, that's absolutely fine as well, especially at the end when I give you the worksheet answers. If anything on there you do want to screenshot, I give you my permission to do that. That's absolutely fine. Whatever's going to help your learning at the moment. Okay, awesome. Right, so you okay if we go ahead, guys? Again, if you want to write anything down, feel free to get a pen. If you want me to recap anything or go in more detail, then stop me. Absolutely fine. Just, you know, shout, hold up, miss. What did you say, etc. Whatever you like. Also, hello. I've missed you guys. It feels very, very weird working from home, but we're getting there. Okay, so first of all, we're going to go through series, then we're going to go through parallel, then I'm going to break down the worksheet and why, to be honest, I got a lot of wrong answers, so that's why we're recapping. So I hope you don't mind. I've written it on paper because the whiteboard. Can you just tell me that that's reading the right way for you? Yes or no, miss, it's backwards? Because obviously I know the camera might invert it on your end. It just doesn't really do on mine. Perfect. My time has not been wasted. Awesome. Okay, so there are a few, but that's just because it helps me to explain rather than me turning around and writing on something. Okay, so first of all, we're really happy with the idea that we've got series. Okay, so series is just one path. The electrons travel in one direction, and that's it. Then, if we add an ammeter, the ammeter will be inside the circuit, and we're really happy with that because the current has to flow through the ammeter to be measured. Okay, so an ammeter can be anywhere in this circuit, but it's represented by the A. Easy. So if I add a voltmeter, this is where the first step where it gets confusing, is this is still a series circuit, but the voltmeter, because it goes across a component, it instantly starts to look a little bit like a parallel. It's not a parallel, it's just showing us the voltmeter going across the bulb. Okay, so it always goes across the component. So those are your first two rules, is that ammeter is always part of the circuit, always has to be in this loop somewhere if I'm measuring the voltage. The current, the voltmeter always goes in parallel, it goes opposite the component. So it's not a parallel circuit, that goes in parallel with whatever component it's measuring. It just plugs in, plugs out, plugs in, plugs out, and you can measure the voltage across anything. And that's what I tried to show on my multimeter. Okay. So when we're looking at series, okay, sorry guys, try and keep the chat a little bit less unless there's like questions. It's okay to communicate, not a problem, but you're just chatting. I love it. It's quirky. Okay, so sorry, in series. So when I'm looking at in series, I have, first of all, I'm measuring voltage. Okay, now just remember your current only flows in the one direction. So your electrons only have that one path. So my arrows here represent my electrons. All the electrons have to go this way. Okay, each of them. So if my battery gives each electron a push of 5 volts, then this bulb will get 5 volts and the bulb will light really brightly. So all the electrons come through, offload the 5 volts, go back to the battery, and that continues to happen. Now that's what happens if there's only one component in a series, in a single line circuit. If I have two components, yeah, Hayden, good point. If I have two components now, what happens is all these electrons, they have to pass through both. If they don't pass through both, the circuit is not complete and it won't work at all. So the electrons have got to pass through both. Now, if they use the full 5 volts of voltage on the first, then they can't continue on to the second. So what happens is if my battery releases a voltage of 5 volts, it will release 2.5 volts on the first bulb, then 2.5 volts on the second bulb. So each bulb will still light, it will just be a little bit dimmer because they're each receiving less voltage. And how that works is each component, the voltage passing through each one will add up to whatever it was at the battery. So if my battery is releasing 5 volts, I know that these will get half each. Okay, so that's your first thing to remember. In series, the voltage we say is shared. Okay, voltage is shared. Current does something else. So we're just talking about voltage for a second. So the voltage from the battery is shared between each component. So the battery will give each one part of the voltage via the electrons. Okay, are we happy with that? Before I move on to the current? Awesome. Thank you, Ben. Appreciate that. Thank you, Oscar. Okay. I'm not sure it crashed if the stream is available. It's the first live I've done, so we'll find out. If not, then I will make a video for you repeating pretty much what I've done here. So don't panic. Okay. So now, when I look at current, so still in a series circuit, I'm still sticking to series circuit. My current still only has one path to follow. All the electrons go that one way. So current is the exact same. So it doesn't matter what diagram I give you, whether I put the ammeter here, or the ammeter down here, or the ammeter here. They are all the same circuit. I'm just measuring the current at 3 different points. And no matter where I measure it, the current will be the same. The electrons have nowhere else to go. So if it's 0.5 here, it'll be 0.5 here, it'll be 0.5 here. It literally doesn't change. It's got nowhere else to go. So current, if you have a single line, a series circuit, will always be the same. Always, doesn't change. Okay. So that's your summary of your series. Okay. Voltage is shared and current is always the same. So then we move on to a parallel circuit. Okay. Parallel circuit. So parallel circuits when you have 2 or more paths. So this is the type that's on your worksheet and that you would have looked at already. But again, it can have 3, it can have 4, it doesn't matter. So this is on the video I said, like the one in my lounge, I can switch on and they'll both come on, or I can switch one off, etc. So most of your houses will run on parallel circuits. So it's got 2 paths. It's got one here, the electrons can come down here, or it's got one here, the electrons can come down here. So 2 or more paths. So when we, if we add an ammeter to it, there's different places that we can add an ammeter in parallel, and that's where it got a little bit more confusing on the worksheet again. If I add an ammeter here, I'm adding an ammeter to measure the current directly from the battery. So I'll recap this again in a minute when I go through some of the answers. But adding an ammeter here means that I measure the entire current. So whenever you've got an ammeter next to the battery, it doesn't matter what side it is, it's measuring the whole current before the current split up anywhere. Okay. If I then add an ammeter next to each branch, I'm measuring just the current going through that branch, no more. Okay, so we'll look at what that means just a sec. So if I add a voltmeter, your diagrams, I think, looked a bit more confusing because your voltmeters were in here as well, which makes it look much more complicated. Remember, the voltmeter always goes across the component. So all I have is I have my battery, my bulb, my other bulb, and then I've just got little voltmeters measuring the voltage of each of those bulbs. So it looks more complicated. It's not. Okay, so again, my ammeter is always part of the circuit. So when I showed you on this last one, the ammeter was always in the circuit somewhere. Voltmeter always across the component. Same in series, same in parallel. So let's look at what the voltage does. Okay. In a parallel, the voltage, the push, will be slightly, it'll be exactly the same. So let's think about it. If my battery here has 5 volts, okay, my battery is giving each electron a push of 5 volts, then the electrons that come down this path will have the push of 5 volts still. The electrons that didn't and chose to come down here will still have had a push of 5 volts. So those electrons can give their full 5 volts to each bulb. And that's because they've got nothing else to go through, because they're just going to join back up and go back to the battery. Sorry guys, the chat is on the side of my screen, so everything you're posting, if I see a question, I'll respond, but I'm just getting a live feed of everything, just so we know. Okay, so my voltage will be the same through here and the same through here, because the voltage, it's not the electrons, it's the push that they've had, and they all had the same push, doesn't matter what direction they go. So for example, if my battery had 5 volts, then each bulb will get 5 volts. Okay, because the electrons here will deliver the 5 volts there, the electrons that come down here will deliver their 5 volts there. So in parallel, voltage is exactly the same. This one is the same as this one, which is the same as the battery. Okay. However, when we're looking at current, the electrons, because they split up, the current will be different. Okay, so when my electrons leave the battery and they travel, half might go down here, half might go down there, and it's always totally random. Okay, we say that current is shared because whatever the current would be here, it's going to be half the amount here and here. Okay, so here's an example. If I have my ammeter at the side next to the battery, like I said a minute ago, that measures the entire current. So all the electrons have to flow through this ammeter. So whenever you've got an ammeter near the battery, it's your full current. If I have an ammeter down here along one of the paths, also known as branches, the paths here, only the electrons that chose this path will pass through that ammeter. Only the electrons that chose this path will pass through this ammeter. Okay, so what that means is if I add up the electrons passing through here and the electrons passing through here, that will be the same as the total up here. So that is why we say current is shared. You add up the ammeter readings from individual paths to get the ammeter reading for the whole circuit. And that was the second thing that your worksheet asked you to do. Okay. So now I'm going to go through some of the answers of the worksheet. I've drawn out the circuits because they looked, like I said, a bit more complicated than they needed to. So I've drawn them out and I haven't put the answers in yet because I'm going to do that so that you can see how I figure that out. Okay, just grab another pen. Okay, I'll try and do them in a bit of an obvious pen. How are we doing? Are we all happy with everything so far before I go forward? Have we got any genuine questions other than how to flip the screen? Who's Aero? Thank you. All good. Thank you, Oscar. Do you mean the circuits and the idea, Sol? I missed that. Guys, can we keep this about electricity? Otherwise, I won't be able to do any of these to help you again. Okay, and I do like the fact that we can interact, but keep it about electricity. Sorry, those of you waiting for the worksheet. I'll be 2 minutes. I just want to make sure that any questions I don't miss. That'd be perfect. But I don't think there are any genuine questions by the looks of it. Okay, so let's go through the worksheet. And again, if you want to compare your answers to what you've uploaded for me on Google Classroom, feel free. I commented on a few that came through early. And if you want, like I said, if you want to screenshot, that's absolutely fine. So the first worksheet asks you about a series circuit. Okay, so when I'm looking at my series circuit, these were your worksheets. Now I'm going to try and go through one at a time for you and pull them up close enough that you can see them. Okay, so this was question number 1. Okay, so in question number 1, it's given you a voltage. So it's giving you the voltage of 1.5. So it's a series circuit. We know that the voltage has to be shared because there's 2 bulbs. So the electrons come through, they have to pass through both bulbs. And if there's a total voltage of 1.5, which this voltmeter is showing us, if one bulb is using 1 volt, the other one will only have what's left. The other one will have 0.5 volts because it has to add up to this up here. Okay, number 2, we're looking here. Same idea again. This top one has 2 volts. One bulb is using 1 volt, so the other bulb must be using the other 1 volts because it has to add up. Okay, so please make sure, those of you on the chat, that you are paying attention because about 80% of the worksheets I had back were incorrect, which is why we're doing this video. Okay, so make sure you're confident with it, then that would be amazing. So let's look at the next 2. Try not to give you too much at once, otherwise I know it's confusing. Okay, number 3. So still series circuit. You've got 1 bulb here, which is using 1 volt. You've got 1 bulb, which is using 1.5 volts. So you add those together to get your top voltage, the entire voltage, the push from the battery. Okay, so 1 volt, 1.5 volts. So that gives us 2.5 volts. Okay, just having a think. 2.5. Here on number 4, so when we have a look at number 4, we can see still same idea. We've got a series circuit and it's still the voltage. So if I have 1 bulb here using 3.6 volts, my total voltage was 3.7. That means that this bottom voltmeter should only be measuring at 0.1 volts. So this first bulb here will be really bright and this bottom bulb will be really dim, barely lit, because it's only getting a very small voltage. Okay. Then last one. So still series circuit, but this one's now measuring the current. Okay, so she's got an ammeter. Ammeters we recognise in the circuit. Now it doesn't matter. They've got about 3 ammeters. That makes no difference because the current's going to be the same all the way through. The current can't change. So if I've got 0.5 in this one, doesn't matter where you measure it, it's 0.5. The current has nowhere else to go. It's got one path. So that one's going to be 0.5 amps and that one's going to be 0.5 amps. It doesn't change. It can't change. Nowhere else to go. So we use that same idea over here. I've got 3.7 amps reading here. It's going to be exactly the same. No difference at all. Current has nowhere else to go. No change. So 3.7 amps. Okay, so if you need all the answers together, they are there. Okay, so the blue is my annotation. That's the gaps you would have filled in. And hopefully that's helping to make a bit more sense. So when you hit the worksheet, they would have looked more like parallel because you've got all the voltmeters in place, which made it look messy. But you need to have the voltmeters there to measure, and hopefully that's a bit more helpful. Okay, any of this stuff you're going to learn? Actually, Waqib, I'm sorry, I'm going to correct you there. I've learned all of this to use for my house, to wire my own switches, to change my plug sockets, to do my lights. To build anything, you need to understand the electrical circuits, parallel and series, as to why things do work, why things don't work. If any of my lights blow, any of my fairy lights blow, if anything electrical goes down, I know how to fix it because I know electricity. Okay, so stay focused. You can do it. Which one do we need the answer to? Extreme moss. What is 1 and 4? I don't know, hold on. So is that circuit number 1 on the first sheet? I'll hold it again for you. So circuit number 1, the answer was 0.5 and it was voltage. Hayden, circuit number 3 here was 2.5 volts. Any other questions before I move on to the second part? That would be, when will we use an ammeter? Ammeters to measure the current. So I would do it, so for example, my car battery. If for any reason my car doesn't start, I'll take my multimeter out and I'll test and I'll check 1, that if there's any voltage in it, if it needs charging, and 2, current, if the current is flowing through it. If the current's not flowing through it, I have a clear blockage somewhere with my electrical wires. I need to clear it, and that might be an easy fix. That's something that otherwise I might take to a mechanic and would cost me 80 quid. That's how I would use it now, but you could use it at any point. Any sort of electrical wires getting dusty, simple as that. If my PlayStation doesn't turn on, maybe it's been sat on a shelf for way too long because mine's up there all exposed, it's too dusty, no current flowing through, I need to clean it, current can flow through, it works. Any other questions? Thanks, Felix. You can go, obviously. Okay, I'm going to just finish up with the last couple for you here. Okay, so on that, I'll just make sure I've got them. Worksheet series. I've lost one of my sheets. Oh no! It's okay. Where is it gone? I'll probably buried it. Sorry guys, 1 second. I put my parallel worksheet down and just need to figure out where I put it. If not, I'll just draw them out for you. Simples. But I thought I had just drawn them all up, so that's a bit sad. Okay, so the parallel sheet. Yeah, evidently I put it away somewhere. I don't know where. Okay, well, I'll go to parallel question 7, 8, 9, 10. Oh, that is them. 11. Oh, it's just I didn't start at 1 again, that's why. Okay, so on the other circuit, on the second page of your worksheet was parallel. Okay, so when we're looking at parallel, we need to remember our rules. We need to remember that voltage is the same and current is shared. Okay, guys, can you slow the chats down a little bit for me, please? I know there's a lot of Minecraft, but I don't want to just take the chats off because that then defies the point of you guys being able to chat. Okay. Sorry, just. Okay, so number 7. Here is measuring current. So we know current is shared because it's a parallel circuit. Okay, so this ammeter is near my battery. So that is measuring the full current for me. So if my full current is 3 amps and I've got 2 paths, I would assume the current is shared. Okay, so I would assume that here I'll have 1.5 amps and here I'll have 1.5 amps. So the current through each path adds up to the current of the whole circuit. So 1.5, 1.5, and then 3. The next one over, number 8, still, it's parallel circuits. We've got 2 branches here. So we're measuring a current, an ammeter reading here of 2 amps. So again, current is shared. So if this is 2 amps, I would assume that it's shared. And usually it'll share equal, not always, but usually. So we'll assume that's 2 amps. If I've got 2 and 2, up here will be 4 amps. Okay, so half the current has passed through this, has gone through this path, half has gone through this path, and then I'm at 4 amps in total. Turning over. Number 9. So again, ammeter reading. I've got an ammeter reading here of 2.5. I would assume that it's split evenly between each path. So this one, I would expect to be 2.5. So if I've got 2.5 and 2.5, my total ammeter reading here would be 5 amps. Okay. Sorry guys, bear with me 1 second. Just trying to think if pausing chat is the best idea and just turning it off for a bit. Okay, so over here, number 10. Now we're measuring voltage. So you've got your voltmeters included there. So yours is all in one on the diagram. I've drawn them in a slightly lighter colour. So I've just drawn them in pen because it's just easier to see. Let's not mess around. It's much easier to see. If they all look the same, it gets a bit confusing. So I've gone like this. So each component, my battery, my bulb, and my bulb have a voltmeter over them. Okay, so the voltmeter is measuring the voltage through each one. So we know that voltage here from the battery is 1.5 volts. So if it's 1.5 from the volts, from the battery, voltage is the same because the electrons that pass through here can give their full voltage. The ones that pass through here can give their full voltage. So my voltage will be 1.5 through each. Okay, so use that idea and you've got your last 2. Okay, I'll hold them both up in a second for you to get the answers. So here, my voltage from my battery, I don't know. The voltage from this bulb, I don't know. Here, it's 2 volts. Remember, it's the same in each component. It's the same as a battery. So 2 volts, 2 volts. Because each electron can give the full 2 volts to either this one or this one because they've gone different paths. Okay, last bit then, guys, and then I need to go, is my battery here. I've got 1 volts here, 1 volts here. So my top one will be 1 volt. It's all the same. Okay, so I'm just going to quickly show you both sheets and then I'm going to sign off for you because I'm due in another meeting. So if you need the answers, then feel free. You probably want it that way around to screenshot. Okay, so those are your answers. Hopefully that was a little bit more helpful for you guys. So we're going to end the stream now. If you have any questions, do come back and ask me. Not a problem. Okay, drop me an email or ask me to make a video of it. And I'm happy to do that. Next time, maybe we'll start without chat. Okay, but thank you guys for tuning in. Well done, 24 of you. That's really helpful. Okay, and have a good week. Bye.